Hi guys, it is Tuesday, March 9th, and this is your day 4 math lesson. Our objective today is to use visual models to add and subtract two fractions with the same units. You do not need to write this. I'll let you know when you do. I just need you listening and watching the video. For our first problem, we're going to solve for the difference, which means we'll be subtracting, using unit language and a number line. For example, here I have 5 ones minus 4 ones. Well, obviously the difference is 1, 1. My next one, if the unit is dogs, 5 dogs minus 4 dogs is equal to 1 dog. If the unit is meters, 5 meters minus 4 meters is equal to 1 meter. And if the unit is sixths, 5 sixths minus 4 sixths is equal to 1 sixth. Now, these were easy. Why? Because they had common units. When you're dealing with ones, you just subtract the numbers and you keep the same unit. Same with dogs. Same with meters. The same goes for fractions. I can show you the visual on a number line. So here's this number sentence written this way. 5 sixths minus 4 sixths equals. So if I had the number line, I would start at 5 sixths, and then I would count backwards to subtract 4 sixths. So 1 sixth, 2 sixths, 3 sixths, 4 sixths. Put my dot, draw my arrow. If this is 0, then I know that this is 1 sixth. So my difference is 1 sixth. When they're like units, it's really quite simple. For problem number 2, I need you to grab your day 4 math packet. You're going to need a pencil. Let's get our names up there. And we're going to start right with number 2. So this time, we're going to decompose to record a difference greater than 1 as a mixed number. So let's start with this problem. Write what I write. 10 sixths minus 2 sixths. All right, we have the same unit. They're both sixths. When that happens, what we do is subtract the numerators. 10 minus 2 is 8, and we keep the same denominators. So our difference is 8 sixths. Now, if you remember, we did this at the very beginning of our fraction unit. Now, I am left with a difference that is an improper fraction. We try not to leave our fractions as improper fractions. They just look funny. So I can change this into a mixed number by using a number bond. So my total is 8 sixths. If I'm talking about a whole, one whole, that is equivalent to 6 6. 6 6 plus what is equal to 8 6? Well, it's 2 6. So I can rename 8 6 as a mixed number. The 6 6 would become 1 whole, and my fractional unit would be 2 6. Let's try another one. 9 fifths minus 3 fifths equals, the units are fifths, so we subtract the numerators. 9 minus 3 is 6. Keep the same denominator. We have 6 fifths. However, that's an improper fraction, so I want to turn it into a mixed number. How many fifths does it take to equal a whole? 5 fifths. 5 fifths plus what is equal to 6 fifths? That would be 1 fifth. So this 5 fifths is equivalent to 1 whole, and the fractional part is 1 fifth. So another way to write 6 fifths is 1 and 1 fifth. All right, so we use the visuals of a number line and number bonds. Now let's flip to our problem set. For 1, we have unit form. So what you're going to do is 3 fifths minus 1 fifth. Well, 3 minus 1 is 2. They're the same unit, so we would label it fifths. That's what you'll do for B, C, and D. For number 2, we are just subtracting. 5 6 minus 3 sixths. Same units, they're sixths. So we subtract the numerators. 5 minus 3 is 2. Keep the same denominator. Our difference is 2 sixths. That's what you'll do through B through F. Now, we're going to come down to number 3. This is where we're going to have improper fractions that we're going to have to change to mixed numbers. I want you to use the number bond strategy. So A's been done for us. Let's go to B. 12 6 minus 5 6. They're both 6, so we subtract the numerators. 12 minus 5 is 7. We keep it the same denominator. 7 6 is an improper fraction. The numerator is larger than the denominator, so we number bond. How many 6 does it take to equal 1 whole? 6 sixths. 6 6 plus what is equal to 7 6? 1 6. So another name for 7 6. 6 divided by 6 is 1, and 1 6. So that's what you'll do for C through F. Let's turn to the back of this page. This is more of the same, except this time all you're doing is adding. So if we look at 4A, you're going to take 2 fourths plus 1 fourth, and 2 plus 1 is 3, since they're the same unit, and we label it fourths. You will do that for B. For 5A, we've got the same units, they're eighths, so we just add the numerators. 2 plus 5 is 7, keep the same denominator. Our sum is 7 eighths. You will do that for B. For 6, they want you to use a number bond for the addition. So if we look at B, 4 fourths plus 3 fourths, the unit is the same. So we add the numerators. 4 plus 3 is 7. Keep the same denominator. we end up with an improper fraction. So how many fourths does it take to equal 1 whole? 4 fourths. 4 fourths plus how many fourths equals 7 fourths? 3 fourths. So we can rename it. 4 divided by 4 is 1 and 3 fourths. And that's what you will do for C through F. For number 7, don't use the number line. Just do it the way we were doing it with the number bond. I think really that's a lot easier. And if you end up with an improper fraction, please turn it into a mixed number. Please bring these papers back to school with you when you come on Thursday.